projections. Okay, and you can think of, for drawings, and you can think of projections as, you know, you're looking through a window, you know, and you see something across the window, and that's, you know, if you were to trace that on the window, that's what you would see, that's your drawing. We pretty much do that all the time when we draw, except that instead of having, you know, the piece of paper in front of you, except for the painter, you have it on the table. So the three kinds are either orthographic and and in this case what happens is you're we're gonna abandon for a moment the notion of where you are, whether you are behind the screen or in front. Okay, let's not worry about that now. But if you have an object and you project onto a plane, usually that object is parallel to the plane. Let's say it's a cube, and the lines are going to also project parallel to that screen. Okay, so everything is square. These lines are all parallel. In this case, this cube is parallel to this plane, and you get an image that pretty much corresponds to one face of the cube, let's just say. Okay, so that's orthographic projection. Now, a variation of that is, I use the old term, which is axonometric. And some people use isometric, but that's a special case of axonometric. It's essentially the same, except that now you have two things. You either have the object or the plane at an angle, either one. You don't have to have both. So what happens is if my object is still, and now it's going to be a little hard to do, but okay, essentially I'm going to, and this is rough, okay, maybe something like that, maybe something like this. So all of a sudden I have a picture that looks more like, you know, a 3D picture. So what's happening though is that these are still all parallel. Now the plane is at an angle. Now if I turn this, you could say that the object is at an angle, right? It's the same thing. And then in this drawing, all your lines stay parallel. So that's parallel to that, that's parallel to this. Whatever, okay? So there is no perspective effect. So the first is orthographic, second is axonometric, and then the third is perspective. And all it means is that the lines in that case converge to the viewer. Okay, so now let's see if I can fit it all. Maybe there is an object here. Again, very rough. Okay, so that one, you might see that it is, let's see if I can do this, starting to get a little bit converging, okay? And then maybe the verticals stay vertical, you know, that just might make things easier, but otherwise these lines are converging onto some points. Okay, so that's all we do. I mean, when we draw, we're really looking through an imaginary. I mean, even when I copy something like this, you know, let's say, that, you know, I'm holding this object in my hand. You know, my other hand is drawing it. You know, something like this. Okay, so my eye is here, and I'm looking at that, right? So normally, I mean, if you're a painter, you would have your canvas here, right? And you would go like this, and then you go back, and then you paint, you know, like that. Or if it was transparent, you could just paint the object directly. But for practical purposes, when we're drawing on the paper, we're kind of doing it here, okay? So essentially what we're doing is we're looking, and then really what we're doing is like imagining that this imaginary plane is now moving here. So you can imagine that it's really amazing all the stuff that happens when you draw something, right? Because really that's what's happening, but we're not conscious of it. And that's probably why, painters use their thumb, they stick their thumb, they put it in front of the object and try to replicate that. But essentially, your screen, your piece of paper, is this plane. I mean, is this window, right? Maybe you can put little curtains on your window like that, and you have a prettier picture. But so remember that, because it's interesting. I mean, and then of course there's a whole science of projections, but that's what we're doing. So let me just mark this so that in the video maybe they'll be easier too. All right, so when we draw this thing, we're just going to pretend that we're doing the axonometric, okay? So everything is parallel. So when we draw it, we're just going to keep everything straight. And we're going to, even though you can flip this thing around, let's just say that for now your verticals are going to be verticals. That is, they're going to be relative to your sheet, they're going to be also vertical, okay, for now. If you were to draw these with your triangles and you were doing what's called an isometric, this would be a 30-degree angle. So it would be the same. But for our purposes, we can play around. Okay, it doesn't have to be so strict. If you buy yourself a sharpener, unfortunately, this particular model they don't make anymore. But it's like the best that I found. But it's nice because it's portable. Doesn't interrupt the flow if you have to come up and sharpen your pencil. Okay, so if we have different kinds of, there are different kinds of axonometric projections. A very simple one is where you take your object and you just project it this way, right? And then what happens is you need to decide, if you were to make this the same width, that looks a little bit more like a deep object, so you probably want to cut it in half. So there's ratios of reduction for the different axes, where in this case, that's one, but in this case, it's half. So another one that we'll do, usually what happens if the axes are the same, right, because that's 30, and this is 30, the ratio is the same, so that these edges are all the same, whatever that is the same length as that. As these angles move, like if this guy moves down here and this guy moves up, then you have to adjust a little bit. So let's try that. Because now what happens is that this is coming to the front, much like this is, okay? Whereas this is going to the back, and you're seeing less of it. So what it will mean is that if you leave this the same ratio, it will look too deep. See that? I don't know if I'm doing this right, but yeah, it's about right. So as this gets narrower, more shallower, then you have to shorten that. I mean, you could forget about all this theory and just try to draw it, right? And that's the other option too. But I just want you to be aware that, these are some of the techniques that were developed to make it look more like the real thing. Okay. For the drawing, I think in the instructions it says something like, let's see, are we supposed to do 6? I think so. To create these sort of bubbles where you're going to inscribe your object. What happens is if you keep the sheet still, then you're going to have a hard time. You probably want to move it around too. But so the layout would be somewhere like this, just to show you where you want to put them. So let's go about how to draw it. For the simplicity's sake, let's just say this is closed, okay? Let's just call that like that, Okay, so it's simpler. And now it's a little constricting here because the space is so small, but when you're drawing, try to draw your lines all at once, the ones that are going in the same direction, you know, like this. And the way to do that is that you keep your pencil kind of perpendicular to the direction that you're drawing. And you kind of keep your arm sort of somewhat stiff, you know, with your elbow and your shoulder, and try to work from your shoulder. You can't see it here, and work from your elbow rather than your wrist. In other words, if you work with your wrist, well, first of all, it would be almost impossible. Think about it. I'm trying to do, well, yeah, it's a lot harder because, so instead, if I go like this, it's just a much, you could call it a more of a like gross motor motion than the fine motor motion. And then what you can do is, you know, turn your paper. All right. So let's see if that's my cube. You know, maybe my other. Just like that. And now I'll do my verticals. I'll line up my paper there. And just do this at the beginning so that you don't have to worry about, oh my gosh, is it right? Okay. So you can see it's too big, right? So maybe I shorten it a little bit. And this angle doesn't look quite right. So just keep moving the paper. So what you could do, by the way, in a lot of these drawings is work and then maybe using a trace to orient it later, or rather do one, then put it underneath and do the final on the other one. So now that I've got this guy, I need to figure out, and I'm actually not paying attention to the proportions now, I'm just pretending it's a cube. I'll get to that in a second. So now let's figure that out, what this thing is. And so that's in the middle. So the way you do that is just put it down the middle. Again, because we're doing axonometric, we're not worrying about perspective, about this point being a little bit backwards. No, we'll just say it's in the middle, okay? So if you bring that up, then I'm just going to pick a point there, and then I'm going to connect the sides. So now I'm making this very, very thick, but for your drawing, you're not going to do that. You're going to be a little bit more fine. So let's see. Again, I'm just using parallels. You see, I'm just repeating the motion. So I'm flipping upside down, get that, and I can probably get the top. And now this guy here is there, and this is like that. Okay, so now I've got the basic shape. Sometimes you might be able to see the other side here. In this case, I don't. Okay, I'm just going to highlight it to show. Okay. Just going through my notes. Now, an interesting thing about axonometric is because you're keeping all your lines parallel, I could just simply turn this around and bingo, now that's my vertical and that's your other view, right? So, I mean, that's really how it happens, but you can also do it with the actual thing. So when you lay it in front of you, just move it around. So for this assignment, you can use pencils. If you want to use a colored pencil, you could use like a Prismacolor. This happens to be a little soft. You might prefer a little harder one, the very thin, the ones that have the, where the section of the pencil is like that, not round. So like this is Prismacolor, and this is very thin. I think it's spelled like that. So this is a little bit harder. Or just use, pencils. So let me see. Good. Okay. So I would recommend doing it freehand first, and then maybe touching it up with like a straight edge. So now if I wanted to get the proportions right, the way I looked at this was, if I remember right, you could measure it, but that would take too long. So what I did was I noticed that, if that's my half point, I noticed that it's about, the proportions is 3:2, right? A little less, maybe. Yeah, it's maybe 2 3/4. I can't tell now. So when you start, right? If I want to make these 2.5 of that, let me just say maybe that's 2. Did I do this right? Yeah, it's about right. Okay. Now you see how bad that line is because I didn't move the paper. So I go like this, and now I'm going to assume that it's a square. You'd be surprised, things that look like they should be square or whatever. Sometimes they're not, but let's measure it. So now I just complete that, and I just do an angle that's, kind of middle of the road without worrying too much about it. Roughly. One good way is to kind of like pick up from the previous line. Yeah. So if I pick up from this line, then you see I keep the motion going. And crossing the lines allows you actually oftentimes to really see where you're going because, where they cross, it's much easier to see if the line is extended. Okay, so now I'm going to pick up the middle point again, and I'm just going to raise it like that, vertically. I'm going to figure out how big that is. You can always use your pencil to make measurements. So that's this much. Oh, whatever, that's 4/5 of half. So that would be this much, maybe. So I'll try to replicate this piece here, over here. Now I'm going to be really obnoxious, and I'm going to make this point below this line so that actually, if I connect this now, I'm saying obnoxious just because when you see something just a tiny bit, it's like frustrating because you want to see more or nothing at all, right? Just for the sake of argument. Okay, so you can see now I'll be able to see a little bit of the other side here. And by the way, by projecting any point on any face to the other side, you can find, you don't have to draw the whole back here and draw the whole vertical, because if you have that point, you can just bring it over, and then there you go, and that vertically. Okay? And I'm just going to eyeball how big that is. Okay, so now that's my structure. So now what I could do is take it's up to you. Some people may say, if I didn't use the straight edge, it's not going to look as good. But that's not really true. If you do use a straight edge, you can then try not to do lines that are like perfect, but try to do lines that are maybe, that break up a little bit. So maybe in the middle right here, I'm leaving a little gap. We'll get into like a bunch of little tricks that you can use to do this stuff. And then when you cross the line, maybe you fade it out. So the line is fading out. Okay? And by the way, I love this gadget because you can, oops, never mind, zoom. Look, isn't that a beautifully faded line right there? It's like science. Yeah, but you can see it, right? See how it just, right there, it just fades out. It's nice. It just makes the drawing more human in a sense. I mean, a computer would have a really hard time doing that for you. So let's keep on going, and now you just move your little triangle, and if your drawing is small, Mike Lean says you can use your credit cards to draw. And so there. So what's happening now is that even though I have a lot of squiggles and lines underneath, the top line now is going to say, hey, but this is the final, right? And literally, you just lift off the pencil on your way out. Think of it almost as an aborted landing. So you come for the landing, you land, and it's like, I gotta get out again. That's the image I can think of. But if it's smooth, if it's a smooth landing, if you're a good pilot, then the first line as well is also faded, right? And then I guess there's like something on the runway that you didn't know there was, and then you have to take off again. All right, we're almost done with this one. Oops. Now, if you did this with a pen, you might be able to get, thicker lines. Maybe not as a good fade out, but and here's my little bit right here, my little orphan. It does help, I think, a little bit. There's another little tip, which is like the hit and go thing, and then when you go, and then if you don't know what to do next, you just keep drawing. It's like, let me think about the next thing I have to do. Okay, this thing. And you can play around with that. And you may decide, well, it's not enough, I want to darken it more. Maybe in the middle. Another approach would be the opposite. Instead of having a little gap in the middle, make it feather. Whatever you do, if it's not even, it's just going to make it more interesting. So now I take that gap away, and I'm going to make this feather. I can even move my pencil around to get a little bit more. And then another little tip is like make a little dot at the end, what Mike Lean calls the professional dot. It's one of these little. He's trying to justify the money that he charges for his workshop, so he puts in words like professional in front of everything. He's really good, though. I recommend taking his workshop. All right. Okay, what else am I missing here? This line. Okay, so that's pretty good. So now what you can do is do different angles, and the other angles could be, like we said, as simple as drawing it like this. You should probably draw it at each different angle rather than just twisting it. And then what you can do is also do some that are sort of like in space, and by that I mean that they don't look like they're resting on anything, right? Because if I do this. That's resting on this space, right? If I do this is also resting here, right? And I think the reason for that is that we always assume, the vertical, the whole thing about up and down and gravity and all that is such a reference point that's so strong that always it tells me, that's the bottom. But if the thing were like somewhere, maybe here, all of a sudden this thing, that still looks too much like, so it's even hard to get away from that model, right? Okay, there we go. Yeah, all right, now I got the angle. So this one would be more like floating in space. Maybe like this, right? And the only way that I would have to, bring it back to Earth, so to speak, would be like if I, maybe I would do a plane here, and I would show that's lying, on that. But so experiment, Okay. Actually, there is a video in iLearn under video demos by Natata. We did them together, and there is this particular one just on line thickness that's actually quite good. And you probably don't want to deal with it too much now for this first exercise, but I'm just going to show you real quick what it shows. It's a simple shape, and it's trying to figure out a little bit of a science of lines for what line should be thick and what line should be thin and what should be in between. And so the theory here goes that the outline is the thickest line. It's hard to do this with the pencil. This is more like when we get into markers and stuff, although you can kind of apply it a little bit. Although the shape you're doing, the carton, is not as complicated as this one. Then lines that are inside the shape, but that still have a plane that's hidden, are a little bit thicker. And the lines that are like the furthermost towards you, which show all the planes connected to it, those are the thinner ones.